Woohoo! Good evening, everyone, and thanks for joining us with vBrownBag. Tonight we're concluding our NSX Ninja, NSX Ninja presentations with Tim Davis. We're going to talk about the edge gateways, distributed firewalls, and design. And we'd like for you to join in to the conversation. You can tweet to us at vBrownBag. I'll be watching the Twitter feeds with the at vBrownBag and the hashtag vBrownBag. We'd invite you to watch our other shows for the different time zones you can see there. And without any further ado, I would like to introduce for the third time our guest, Tim Davis.
I'm so glad to be here again. I was telling Tom a little bit ago before we started broadcasting and all that, as much as I'm glad that the series is wrapping up because it's been 3 weeks, at the same time, I wish there was more because I really like talking about NSX and the presentations have been going really well. So if you could pass me the ball.
Sure thing.
If it is called a ball on this one, I have no idea.
I'll pass you the baton.
Close enough.
All right. I see your screen.
Cool. So we're going to go ahead and start off here. Today we are going to go over the Edge Services Gateway, the Distributed Firewall, and a little bit of intro to design. Really, not a whole lot. I could do an entire week straight on design. I could do an entire week straight on Distributed Firewall and Edge Services Gateway. So we'll just kind of blow through these and we'll kind of try to hit all the things that we can here in the limited time that we've got left here. So, whoop, I clicked away from it. There we are. So the NSX Edge is really the ingress and egress point, the barrier into your NSX environment. So when you do deploy NSX out there, you start doing virtual networking, most of your features and everything are going to come through the Edge Services Gateway. Now, this is an appliance that gets deployed out into your environment. This isn't part of our distributed topology like the DLR or the distributed firewall. So this is a point where your data is going to traverse through a virtual machine. So if we look here, this is kind of an overview of the services offered by the Edge Services Gateway. This is going to be firewall, and this is a stateful layer 4 firewall, just like distributed firewall. And as I alluded to in the past couple of weeks, the firewalling that happens on your Edge Services Gateway is completely separate from your distributed firewall. One of the reasons that's super important is because depending on how you deploy your Edge Services Gateway, in what form, if you're doing like an equal cost multipathing, you lose your stateful services on that edge. Now, why that's okay is that you're still doing stateful firewalling in kernel with your distributed firewall, and we'll talk about that a little more in a bit. So looking over at the services here, layer 3 through layer 7 services. So you're looking at DHCP DNS, routing NAT. Edge Services Gateways are where we do our VPNs. We have a couple of different types of that. The load balancer. So when you deploy an edge, you can deploy an edge to be a full edge router with firewalling services and all that, or you can just deploy an edge out just to be a load balancer and do nothing but load balancing. If you're doing a one-armed or inline, you deploy an Edge Services Gateway that does nothing but load balancing. So the benefits for this, real-time service instantiation. So we can go ahead and deploy all of these services right when you need them. You're not having to go out and deploy a physical appliance, rack and stack it, cable it, give it IPs and all this kind of stuff. All of this is done with the same kind of quickness that we can give you with other networking services. It is an x86 compute form factor, and I think I just skipped past that. So again, this is a virtual machine that runs in your network. You don't have to go out and physically deploy this. When you go into NSX and you throw API calls for an edge, or you go through and you click the settings for it, it will automatically deploy this from your NSX manager. So this is a quick look at our reference architecture for edge services. If you notice, we're kind of adding on a new rack to the standard VMware recommended topology, where you have management cluster as well as compute clusters. In the NSX reference architecture, which we'll go over at the end, we add an extra cluster called the edge cluster. And what this is this is where all of your ESGs are deployed, so that you're only connecting your northbound and southbound traffic through one specific cluster. Everything else from your compute to your management is all east-west. And we'll kind of go over that here in just a little bit. So let's take a look at some of the specific features. Yes?
Sorry, I keep interrupting you.
No worries.
A question that came in from Twitter, and I think it's a fun question. I don't know if I would ask more clarification, but it says, if we're running native VXLAN, can we also run NSX on the same network? I'm not sure exactly what Graham meant there.
So this is kind of like somebody asked this when we went over switching and routing last week. For instance, VXLAN is run on Cisco's ACI fabric. You absolutely can run NSX doing VXLAN on top of an existing VXLAN, whether it be Cisco's or somebody else's. The only thing that's required there is the extra header room for encapsulation, because VXLAN adds that 50-byte header. So if you're double encapsulating, you need 100 bytes extra, as opposed to just a standard 50 bytes that we normally ask for. So as long as you have the MTU size for it, you can absolutely run double encapsulation like that, running NSX on top of a different installation of VXLAN.
I got it now. Thank you so much.
Yes, sir. So going back here, we've got the Edge Services Gateway. So it does run firewalls, NAT, DHCP. Last week, we talked about having overlapping IP spaces on ESXi hosts, mainly used for things like application lifecycle or development and things like that. NATing at the ESG is how we do that. So you have your two VMs that are 192.168.1.1, but they're behind different ESGs using NATing in order to get in there. So that's kind of the mechanism to make that work. Routing, we do at the ESG. Now, this isn't like your distributed routing. This is going to be, standard routing from that one standalone machine. It's not distributed all across all of the hosts like the DLR is. Load balancing. This is the big feature that we have in ESG. We absolutely can do some crazy high performance load balancing, including SSL offload load balancing. Really, for the most part, if you're using F5s in your environment, most likely you're not using like web application firewall and iRules and everything like this for all of your workloads. Most environments have some really basic load balancing that even if it's high performance and SSL offload, you're still doing like one VIP to a pool of EMs. And we can absolutely take over load balancing for that. Site-to-site VPN. So before multi-site NSX was really a big thing, we were able to use Edge Services Gateways to do site-to-site VPN and kind of stretch that. If you're doing things like mergers and acquisitions, or bringing in other environments or consolidating data centers, using site-to-site VPN can be very helpful through the Edge Services Gateway. SSL VPN. So if you've got remote contractors and things like that that need access to your environment, there are some other solutions. Cisco has one, Palo Alto has one, and they kind of allow you to, just VPN into your environment. You can use the Edge Services Gateway for that. We have a client for just about every major OS there is at this point. And then the big one here, Layer 2 VPN. So the thing used, mostly what this is used for, is when you're migrating VMs from VLAN backport groups into VXLAN backport groups, or if, or if you're, setting up a site-to-site where you need a technology without the use of hardware like OTV, you can use that L2 VPN. And of course, high availability. So we have a few different ways that you can deploy ESG that allows you to have high availability on that, whether it be just active standby or the up to 8 of them in an ECMP fabric. And then of course, DNS relay with syslog. all of our stuff, whether it be the distributed firewall, the ESGs, NSX manager, everything can do syslog. We can dump all of that out to the syslog you already have, or we can, of course, use any other syslog aggregator or Log Insight, which with NSX, when you buy NSX, you automatically get Log Insight. It comes free with it. Whether you have one tiny site or a bunch of sites, you get as many OSIs as you need to cover your entire NSX environment. So that's cool. So looking at the NSX Edge and the DFW with a security comparison here, distributed firewall is going to be mostly for your east-west stuff. Obviously, because we're distributing that load across all those ESXi hosts, and all of your VMs are able to move around, they keep all that firewall information. The Edge Services Gateway firewall is still set from the same place, but those are just mainly for north-south traffic coming in and out of an NSX environment, whether it be a tenant or your overall environment. There's multiple sizes of Edge Services Gateways. Compact, large, quad large, and XL. Really, for the most part, I mean, I've never seen a compact used unless it's like a home lab. Large really is semi-common in really, really small environments. Quad large is mostly I've seen that when it comes to just needing like a lot of firewall rules and stuff like that at the edge. If you're going to be doing any form of load balancing, you should be using extra large. And those things are sized to handle the connections per second and everything that you're going to get, really needing for high performance load balancing. So this is just kind of a look of the UI for configuring Edge services. Bear in mind that some of these screenshots that I may have may be a little out of date due to the fact that the content was built a little while back. So if I see something specifically, I'll point it out, but this is pretty good. So you can kind of see a little bit of the settings here for the configuration of an ESG. Form factor conversion. So when you deploy an ESG and you deploy it, say you want to start out at compact, you can actually go through and convert it to large, extra large, quad large, and all that, just with a click of a button. It'll go out and it'll redeploy a new edge. It'll back up the config, dump the config over, and then it'll do a failover to the new edge. So interface-based routing and firewalling. Your OSPF, your iBGP and eBGP, all of that is peered upstream to your physical devices through your Edge Services Gateway. We talked about that a little bit in the routing last week, where when you're doing a distributed logical router, you've got that little control VM that peers upstream to your ESG. Your ESG is then what peers upstream to your physical devices. This is going to be your north-south routing point. So for scale and performance, this is up to line rate performance with a scale-up architecture. So with the ESGs, at this point in time, you're getting roughly 10 gigs of throughput per device. In the future, you can see that being kicked up a little bit. We don't have anything specifically coming out, but they're looking into technologies like Intel DPDK, which essentially allows you to write the packets directly to the NIC instead of having to pass those packets through the TCP/IP stack. There's companies like Viata that are getting 40 plus gigs of throughput through a virtual machine. So definitely look for more, performance than 10 gigs. But at this point in time, we see a lot of customers that don't really have more than 10 gigs of north-south traffic coming through one ESG. If they do, then that's when we recommend things like equal cost multipath routing through ESGs, where we can aggregate those together for up to 80 gigs. So the NSX load balancer on the edge. Lots of different things that we can do here. We can do a little bit of application rules, nothing really crazy. We do have a scripting language that's available, just like F5 does. If you've got some like really, really crazy context rules and web application rules and stuff like F5's got, we're not going to be able to compete, which is why we have the partner integration with the virtual F5. But I believe the rule of thumb that we've seen is generally about 80% of the load balancing that most customers have in their environment is pretty basic in the grand scheme of things. Even if it is like really huge pools and high throughput and all that, huge connections per second, we can handle that. We can absolutely handle performance. Just some of the really, really crazy context stuff that we're going to let F5 do what F5 does best. But if you need IPv6 support, we've got that. If you need SSL termination, certificate management, we can handle that no problem. We've got lots of different health checks in the environment. So you're not just looking and saying, yeah, is the host up? Great. You can kind of see the connections for the host. Is the host stable? Is everything going well with your load balancing environment? You can have multiple virtual, oh, go ahead.
We have a question in from Ken. Ken asks, he says, it's nice that an NSX edge can be scaled up. Can it be downsized at a later time if desired?
It cannot. So we can scale up, we can't scale down. So what you would need to do then is to deploy out a smaller one and move your connections and your configuration and stuff over. So if you do want to scale up, make sure you know that you're not able to go back. All right.
Thank you, sir.
I got another couple of questions, but I'll let you finish the load balancer. There is one thing that I had heard, and maybe you can confirm it.
Mm-hmm.
I heard that basically the load balancer can do everything HA proxy can do.
That is absolutely correct.
All right.
And there's 3 guesses on why that's true. You're only going to need one.
Exactly.
Guess where our load balancer is based off of.
Mm-hmm.
So if you are familiar with HA proxy is a fantastic load balancer. That's what ours is based off of. Now, we didn't just take HA proxy and slap it in there and we're good to go, because you're going to get some of that VMware secret sauce thrown in there. But absolutely. So if you're looking for comparisons of performance and stuff like that, you can definitely, compare apples to apples a little bit. So logical VPN, user and site to site. So user VPNs are extremely important for companies that have like offshore contractors or road warrior workers and stuff like that. We've got the ability to deploy a client out on Windows, Apple, Linux, and all that, and give you access into your environment just like any other VPN client would. Also site-to-site VPNs. So if you've got multiple data centers or multiple remote sites, you can deploy edges out there and create IPsec tunnels. Now, one cool thing that you might also be able to do with this is if you could deploy an edge services gateway out into maybe a public cloud somewhere, what would stop you from setting up a site-to-site VPN, allowing you to have that connectivity between on-prem and the cloud? So it's high performance, 2+ gigs per tenant. When you're doing VPN, you're not going to get that full, up to 10 gigs line rate kind of thing out of the ESG due to the fact that it's still doing its other functions. But you can get 2+ gigs of throughput per tenant. Now, that doesn't mean that you get 2 gigs, period. That means per tenant. And when we think tenant, we say ESG. So if you need more than that, you can split out and deploy multiple tenant ESGs, giving you that extra space. Use cases for this, cloud to corporate, of course, cloud onboarding. So if you're kind of spinning out new workloads, spinning in new workloads, having that connectivity is definitely helpful. Also, remote branch office is a big one. This is a little bit outdated in terms of information because we now have the NSX Robo SKU, which is a little bit different in how we manage things, and it's priced completely different. So if Robo is a big use case for you, definitely reach out to your NSX SE because we're doing some really cool stuff. And of course, the layer 2 VPN, if you need that stretched layer 2 connectivity between, say, on-prem and a public cloud, we can give you that L2 connectivity. This is SSL based, web proxy support, and broadcast support. So with this, you're also getting that 2+ gigs per tenant. If you need more, you can do multiple tenants. Those are different routing points though, so you won't be able to have everybody aggregate through for the VPN. For
Tim,
ESG,
before
yes,
you
sir.
go on, a couple questions from slides back. Is the SSL offload able to use the newest Intel instructions for performance? Do you know if using any particular, I mean, obviously it tends to be that newer servers are better. Do you know if NSX is
Yeah,
taking advantage?
that's a great question that I don't know off the top of my head. Ping me on the side, whomever asked the question, or Ariel, let me know, and I can get you all the info we have up to date on our load balancer for offloads. I do know that last time I saw a load balancing presentation, they did definitely talk about using hardware offload for that in the sense of what Intel's doing. But for the exact answer, I'd need to look that up for you.
No worries. And the other question is maybe more conceptual. Is the ESG up to being a border firewall?
Okay. Your NSX-SE will never, ever, ever tell you to get rid of your perimeter firewall, period. If they do, you need a new one. That's not to say that the Edge Services firewall is not fantastic. But at this current point in time, with the way data centers are architected, we will never tell you to get rid of your perimeter firewall. Now, that's not to say that you won't have your perimeter firewall out there peered directly down to an ESG. And maybe someday in the future that may change. But as of right now, really, when it comes to your actual data center, leave the iron in place. Let it do what it does best, and just throw the ESG downstream from that. I wish I could tell you otherwise, but right now we can't do it. Not to say that it couldn't handle the job. It's just the recommendation right now.
Cool, thank you.
So ESG high availability, heartbeat and synchronization. These things have L2 connectivity using the same port group. They do heartbeat to each other. Anti-affinity rules, they're automatically done for edge services gateways when it's set to high availability. Yes. Unlike the controller cluster, where you do have to manually set anti-affinity, that's automatically done for the ESGs. And I believe that's going to change at some point. So if we look, we have the active standby model. There is a failover timer of 15 seconds. You can tune these timers down. And as soon as there's a dead timer, it flips over. So with modes of configuration, you have advanced and manual. And you can kind of let it do its own thing, or you can actually go in and set the HA stuff up yourself. And here's some of the failover behaviors. If you want to take a screenshot, by all means, or I can send the deck out again if need be. It just kind of talks about what happens in failure scenarios. With the stateful firewalling, it's going to synchronize the connections over and then fail. And it says failover to standby in 15 seconds, but of course that can be configured down to 6. So do we have any more questions on this one at this point? No,
I'm not seeing anything on Twitter.
All right, so let's go ahead and move on to the distributed firewall. I'm a little behind, but I'll make it work. So, firewall placement and evolution. This is what we literally just talked about. You've got the standard architecture where you've got the firewall at the edge of the network. That comes down and that kind of handles firewalling for everything, north, south, or east to west. Although in this traditional model, we found that most customers just aren't firewalling east-west. Or they're setting up VLAN sprawl everywhere, and they're basically traversing everything from VLAN to VLAN through a firewall. This is hairpinning a lot of traffic, and it's really pushing those physical firewalls up where you're needing 20, 40, 60, and 100 gig interfaces. And if you've ever priced out a 100 gig firewall or a 40 gig firewall even, it's expensive. So then we kind of evolved into yesterday's quote-unquote virtual infrastructure, and we've kind of put a firewall inside of each VM. That's like the Windows firewall and IP tables and Linux and all that. And I mean, if a box is compromised in any way, what's the first thing the person's going to do? They're going to go in and either service IP table stop, they're going to kill it, or even worse, they're going to go in and they're going to inject rules so that they can traverse around the network without you knowing that the firewall's been shut off. This is all well and good. It's hard to manage at scale. So we've kind of evolved now with NSX into having our distributed firewall, where that firewall is implemented at the hypervisor level and it's distributed across all the hosts. So if we kind of look here at the overview for DFW, they say no choke point, really due to the fact that we're kind of spreading all the services out. We're firewalling just about everything in your environment. You're not really having to hairpin all that traffic over through, and you're not taking 39 gigs worth of traffic and shoving it through a 40 gig interface, or 41 gigs of traffic through a 40 gig interface. You're really kind of spreading that load out. We're also moving enforcement as close to the workload as possible without bringing it in band of the VM. That's a really important distinction with that. So bringing it to the VNIC level, it is as close to the workload as it can possibly be without being inside of the host where it can be shut off if it's compromised. So that's one thing that we really pride ourselves on, is keeping the firewall still out of band of the VM, but still as close to the workload as we can possibly get it. It is scale out. Now, technically, if you want to split hairs, if you have one 10 gig card in there and you put another 10 gig card in there, you've just scaled up. But really, for the most part, we're scale out. So if you've got all this traffic in your environment and you need more firewalling, most likely you're going to need more compute as well. So you throw another host in there and you've got another, up to 20 gigs worth of firewalling. Now it says line rate performance 15 plus gigs. That's actually changed since then. You will get 15 plus gigs, but on our last performance testing, if you've got 20 gigs in your host, you're going to get like 19 and a half or more gigs of throughput on that, especially if you've got things like receive side scaling and larger seed offload and stuff like that configured, as well as VXLAN offload on the NIC, so you'll get a lot more performance out of them. So the distributed firewall provides security filtering functions on every host. That we're turning every single one of your hosts into the firewall, doing layer 2 through layer 4. And again, this is stateful firewalling. So we're also offering centralized configurations, and we're doing that through our distributed firewall configuration. And that not only does distributed firewall, but it also does edge firewalling from there as well. If you're using a partner like Palo Alto, at this point in time, I believe it's just Palo Alto that's allowing you to do it, but you can actually use Palo Alto's Panorama to configure distributed firewall. Before, when you needed to redirect traffic into Palo Alto, you were having to manually create the rule in DFW for that redirection. Now, when you create a rule in Palo Alto, it'll push down the redirection into DFW. So if you've already using Panorama in your environment, now you can do all of this cool new distributed firewalling in kernel still through Panorama. That's not important. Well, I guess it is. VM name and attribute and stuff like that. Really, we're able to pull all of this crazy context from the distributed firewall since we are connected to vCenter. So we can pull all kinds of things, the VM name, what OS is running, and all of this. So you're building policy not just on 50,000 lines of 5-tuple IP scheme, you're building it on what your business looks like. This group to this group, or this VM to this VM, or even this person can access these specific resources. Now, distributed firewall can enforce security no matter what, whether it's on VLAN, VXLAN, or even on the same layer 2 segment. Now, if you're familiar with networking, firewalling on layer 2 is impossible unless you're using something like PVLANs or something like that. If it's on the same broadcast domain, it's really, you can't really jump in there. With distributed firewall, since we're doing it at the VNIC, even if it's on the same VLAN, we can absolutely do policy enforcement. Now, if we look here, we are enforcing at the VNIC, and that's whether it's encapsulating with VXLAN or not. It gets checked before and after. And I'll go here. I thought my little thing was next, my visualization. Oh, well. So let's look at the components here real quick. vCenter server talks to NSX manager. As we talked about before, this is one-to-one pairing. You're never going to have one-to-many or many-to-one at this point. It's just, you got it, one-to-one. Your NSX manager then talks directly down to your ESXi hosts for DFW. That's even if you have virtual networking or you're using the controllers. In that scenario, your NSX manager is talking to the controllers for virtual networking. In distributed firewall, no matter what, it's talking directly through to the ESXi hosts for enforcement. There it is. So here's my little visualization of a packet. It says VSFW, and it's above the vSwitch. I actually like the way that this is built. So we're using a technology that's built into your ESXi hosts called the DV filter groups, or DV filter slots. Now what this is, if you can think of your virtual machine as a physical server and your distributed switch as a physical switch, you've got that little Ethernet cable that's connecting the two. On that cable, there's 16 little slots. The first 4, they're reserved for ESXi. The last 4, those are also reserved for ESXi. Those 8 in the middle, those are the sweet spot that we can start to connect into. When you connect an ESXi host and you prep it for NSX, and you give it the distributed firewall module, distributed firewall locks into slot number 5. Every single time data traverses out of that VM, it clicks through every single one of those little slots. When it goes through the first 4, it's all fine and good, it gets checked. Then it gets to number 5, and it checks. Do I have a distributed firewall rule that says that this traffic can or cannot go? Yes or no? If it gets yes, it gets passed on. Now, if you're using a partner like Palo Alto or Checkpoint, it's going to register into that next slot. So it goes, hey, I passed the distributed firewall, but I know that I have to get checked by Palo Alto. That's when it clicks into the next slot, and it gets checked over into the Palo Alto service VM. Once it gets done with that, if it passes, it gets put right back on the chain and sent through. So if we look at the visualization here, that packet's actually being checked 4 times, going from source to destination. Twice on the way there, twice on the way back. So depending on how you have your policy set up, it could get dropped on one way but not the other, or on the way back but not the way out. That all depends on how you design your policy. The same thing happens whether it's going over to a different host. It's going to get checked that same 4 times, 2 on the way there and then 2 on the way back. Let it finish, go faster. There we go, okay.
Does that add much latency or any sort of noticeable?
It does not. So this is one really cool thing. When we talked about performance last week and the week before, your distributed switch is already busting that packet open. I mean, it's already happening. So it's making that layer 2 decision. With NSX, we're saying, while you have it already busted open, check for layer 3, and now check against this firewall table. So in the grand scheme of things, we're not adding a lot of overhead for what it's already doing. Our scale numbers, last time they came out was roughly 1 to 4 or 1 to 5% of 1 core of the CPU and maybe 4 to 6 gigs of RAM. If you have receive size scaling turned on, which opens up more cores for network processing, you're talking 1 to 5% of 4 CPU cores. In the grand scheme of things, with really loaded ESXi hosts, you're talking maybe 1% of the compute infrastructure as overhead for NSX.
We actually do have some questions that came in too from that. Thank you
Cool.
for answering.
Let's do it.
That was my question. But we have a question: can we manage NSX using the HTML5 client?
Absolutely not. And I wish I could tell you otherwise. I really do. They are working on the HTML5 module, but at this time, SRM and NSX specifically are still using the web client. You can definitely see that changing in the future, but as of 6.3 that just came out, it is still in the web client, and I'm sorry for that.
And another question is, can it be AD integrated? Can it do RBAC, that sort of thing?
Yes. So we absolutely do RBAC. So we can say not only security people can come in and make firewall policy, or only network people can do network things. We can also do identity-based firewalling. The big use case for that is VDI, where we can say when a finance person logs into their finance VDI, they get a specific finance policy. If that user logs out and a domain admin logs in, they immediately get everywhere. And we can do that with Active Directory integration.
And does Active Directory integration stretch into creating rules for the firewall?
Yes. Yes, we can build policy based on Active Directory groups and users. And again, the big use case for that we've seen is VDI.
That's amazing.
So policy rule objects. We can create objects based on layer 3 and layer 4 stuff. We can do even layer 2 rules, doing things like ARP and LLDP blocks. Our rules are processed top down through the Ethernet tab and then the general tab. So it's going to do all of your layer 2 rules first from the top down and all your layer 3 rules and 4 rules from the top down. I was asked before this even started about how to design policy. Since it is top down and creating groups and everything, your blanket policy will be at the bottom. So if you are a zero trust model, it'll be deny all at the bottom. And then up above that, in order of how they would be hit, you would have your rules whitelisting that traffic. Otherwise, you would have a bunch of denies with a allow all at the bottom. But really, we'd like to try to help you get to zero trust as easily as possible. This is kind of a look at our centralized management screen. You can kind of see that it is, source, destination, service, and action, just like any other firewall, but you're not seeing a bunch of IPs everywhere. This first source does have some IP sets, which we can use, but then if you look and you see like engineering traffic, VC containers, so we're looking at clusters and all that. If you look at the engineering group, it'll actually show you which specific things are in there, if it would ever get to one of those. Okay, either way, all of that's click. Yes, sir.
I do have a question from Josh Andrews.
Of course you do.
How is AD pulled?
One more time. How is it pulled?
How is it pulled?
So when you go in and you go through the configuration and you connect it to Active Directory, it goes through and starts scraping those groups. When you start to create firewall policy based on Active Directory groups, it'll actually go through and connect out to AD and pull in the groups that are available to you. And you can search through them and add groups.
So you don't have to do any separate configuration from what vCenter does?
Yes. Yeah, you have to add it as a data source basically inside of the NSX manager config.
Got it. Okay.
You do have to set it up separately. And it is a separate configuration for IDFW than it is for the RBAC stuff. The RBAC configuration is one thing, and then identity-based firewalling is another.
And would this count as a solution in the PSC?
One more time?
Because I remember that the PSCs had a definite number of solutions that they supported, especially if you did an embedded PSC. So since you said that,
yes, I believe NSX does show up as a solution there for that.
Awesome, thank you.
Mm-hmm. So sections, these are one way that we can use to kind of group rules together. It is still top down, but you can set up groups. So we've seen this a lot where companies will do like rules for application A, rules for application B, and they'll be kind of into a set of rules. Sections do not impact overall security policy. It is still from the top down on the rule set. If you do have masked rules, where basically one rule will not be able to be hit because there's a rule above it that keeps getting hit, a tool like vRealize Network Insight will show you this, and that's kind of how you can fix your policy or build your policy a little bit better. Definitely go back and look at the vBrownBag that was recorded the week before I started. It was Sean Odell doing vRealize Network Insight. If you have questions on designing security policy for NSX or anything like that, that's the tool that we use to design security policy. That tool does everything you could want to do in terms of planning for microsegmentation. So policy rule object field, this is just kind of looks like what we can build policy off of. IPv4, v6 addresses, that's standard. The data center. So you can have it say rules for any VM that's in the specific virtual data center, or rules for any VM that's in the specific cluster. And you can go all the way down to setting a rule for a specific VM VNIC. So if you have a VM that has multiple VNICs, you can set security policy for the different VNICs in that VM. The biggest thing that we've seen is security groups based on virtual machine name, or even the OS that it runs. Services. So we've got a ton of different preset services that are in there, but you can also set your own. NSX Distributed Firewall also does ALG, or Application Layer Gateway. The big thing for this would be Active Directory. So Active Directory uses about 20,000 ephemeral ports in a really high range. If you're trying to firewall this, then you're either having to go through and open up all of these different little pinholes and leave them all open, or you can go through and say, well, I only have 100 users, so I'm going to change the registry in Active Directory to have it only use 100 of those ports. That's all well and good, but we can actually go through and say, great, we know that's an Active Directory server. We know it uses 20,000 ephemeral ports, so we'll go ahead and allow those ports on a socket-by-socket basis, and then let those through and then close the port when it's done. So that's a really, really cool thing that we can do here with our firewall. Now action, we have block, allow, log, do not log. This is a little out of date because we also have redirect and copy now, and you can either log or do not log with that, or allow and block with that. And what that is if you're using something like a Palo Alto, then you'll redirect into Palo Alto. If you're using another third-party solution like Gigamon, then you can copy, and you can either block or allow and copy and log. So there's lots of different actions that we can do here. Now the applied to field is extremely important in terms of designing security policy. So the applied to field says where the rule is set. A lot of times we see it done to like a logical switch, but you can also apply a rule to a virtual machine. So if you have a rule set up that says this VM can't talk to this VM, but you have the applied to field set to say a third VM that's not involved, that rule will not be enforced because it's not applied to the VM in question in any way. So that's just another field that comes in when you're actually designing the distributed firewall policy. Here's just an example of a logical switch rule. Now I'm running a little behind, so I'm going to kind of skip through the example here. Security groups, these can be static or dynamic. This is by far one of the most important things when designing security policy for NSX. You can have a static policy saying, well, these 5 VMs are part of this thing, so I want them in there. Or you can do a dynamic policy and say, well, any VM with an OS of Server 2003 gets in my quarantine policy. Or any VM that has web dash in the name gets the web policy. You can also use things like security tags. So if you're deploying using a cloud management platform like VRA, you can deploy it out and say any VM in this stack gets this security tag. As soon as that VM object is instantiated, before the VM even turns on, it automatically has its security policy based on the security tag or the security group that it's in. Now you can also set up security groups with regular expressions, and we can also do static inclusions and exclusions. So you can say, I want all of my Windows servers to get the Windows policy, except my templates. I need those to have no policy. That's one use case that we've seen used for that. A little example. The applied to example, and if you guys want to take a look at these examples, just let me know and I can send that out. Do we have any other questions pending? If not, I'm going to move into the design piece for the last few minutes here.
No, sir.
All right. Design basics. So we're going to kind of, like I said, putting it all together. We're going to go over a few of the things that we did before and just kind of round out the last bit here. So we talked about a lot of things over the past few weeks, lots of different components like the virtual switch, the NSX manager, the VIBs, distributed firewall and load balancer and all that. Knowing how they kind of come together is super important. The biggest use case that we have, maybe 60% or so or more of our customers that buy into NSX is security, microsegmentation. And that's due to the fact that it's the easiest to implement. So a lot of customers see the benefit in having the full, shebang with network virtualization, VXLAN, and all that cool stuff. But staging your design and implementation, saying, well, we'll just go ahead and deploy it out and we'll use microsegmentation. We can use VRNI to set everything up and it'll be great. Then eventually for phase 2, we'll set up the network virtualization and we'll migrate things into VXLANs. That's the biggest use case and phased approach that we've seen at this point. The second use case is automation. Customers that are looking to kind of speed up, you'll hear the term DevOps a lot, and I'm doing air quotes and you can't really see that right now. But if you're looking at spinning up virtual machines faster, using a little web portal so your developers can click a button and get VMs and stuff, why would you not use the networking and security piece of that as well? Because we've got customers that are on this full push to deploy VRA, but they're like, no, we don't want to do NSX right now. So they want to go out and deploy a bunch of VMs real quick, but they still have to cut VLANs and assign IPs out. They still have to wait a week for security policy. Really, what's the point in doing all this VM automation if you're not going to round out the entire stack and deploy the whole thing at once? You still have to wait 3 weeks for security. It's not really that much faster. So we see a lot of customers that are implementing NSX as well, whether it be VRA or OpenStack or even just scripting. That way you're deploying everything at once. So this is a typical architecture, and this is one thing, if you've ever looked at the hands-on labs, maybe you've taken the VCIX-NV exam before, this is a really, really common architecture where you've got logical switches, you've got a distributed logical router, you've got a transit logical switch, you've got an NSX edge, and you've got it routing peered from the DLR to the ESG and upstream. This is really kind of showing you everything we've got in terms of network virtualization, all in one really basic looking architecture. So design aspects. If any of you are VCDXs, are looking to do VCDX, or you don't know what VCDX is, but you know you like to hurt yourself, definitely start the process. I recommend it, but you'll realize that you've been working in tech for a long time, so you know all these tiny little nerd knobs. All of those nerd knobs become design decisions. And you have to be able to tell somebody why you made that decision. And when it comes to developing business cases and making a true design that supports a business, it's all well and good if you want to tell them, well, we went with an all-flash vSAN because we thought it was cool. Well, they're going to ask you why you had to spend the money on that. How did that help the business? And just saying, well, it's cool and it's fast doesn't really do that. So when it comes to designing NSX, you really need to think of, what are my business drivers? How do I take all of these features and all these cool new stuff and map it back to my business requirements? Now, if they have a business requirement of be badass, then done. Every single design decision you make will fit business requirement 01 of being badass. So looking at physical fabric options with NSX. I said it before and I'll say it again. We're always going to say we don't care. We kind of care. Really, for the most part, we don't care what brand it is. We don't care what topology it is. If you have a stable fabric that meets a few basic requirements of, can you ping from here to here? Yes. Do you have an MTU that works? Yes. All right, let's do this. So we see leaf spine a lot these days. A lot of customers want to go that route. They're looking to go that route. That is a favorite, but we don't need it. You can be 2-tier, 3-tier, really whatever. Keeping your physical fabric in mind when deploying NSX is extremely important, because you need to know, do I have the MTU to go where I need to go? Do I have the round trip time from my 2 sites within 150 milliseconds, which is what we need for VXLAN? All of those things get compiled into your design decision list. So looking at the cluster design, I talked about this just a little bit ago today. We're kind of adding in that third cluster for your standard vSphere design. So vSphere best practices is a compute cluster and a management cluster, separating those workloads out so that your management doesn't run over your compute. A big driver for this is generally you're not going to need to size your management cluster hosts as large as you would for your compute clusters. Now with NSX, we're adding in that last cluster of the edge cluster so that you can have that north-south traffic traversing just through one cluster, and everything else internally is going to be east-west. Now, what this looks like in terms of this design is now, instead of doing what most network admins do and trunking everything down to every single ESX host and letting the VDS do the VLAN tagging, now you're only trunking your management and your VXLAN transport to your compute and your management. All of your north-south VLANs are being trunked down just to your edge cluster. So design decisions for multi-VTEP. I owe Josh some info on performance with multi-VTEP and all that kind of crazy stuff. I haven't forgot about you, I'll get it. But there are just some decisions for going multi-VTEP. Generally, if you're doing some like crazy high throughput stuff, or you need true, there is no single point of failure anywhere, you would go multi-VTEP. Most of our customers are single VTEP, but there are some kind of teaming and failover modes where you cannot go multi-VTEP, and that's LACP, route based on IP hash, explicit failover, and physical NIC load. You cannot use any of those teaming policies for multi-VTEP due to the fact of how we're handling connections for VTEP. If you do want to use any of those, then you can do single NSX VTEP. Now, if you do want to do multi-VTEP, you can use originating port and source MAC hash. Those are extremely popular. So there's a giant transportation company here in my area that's doing multi-VTEP for their deployments. And they're going to be using source MAC hash for their teaming and failover mode. Transport zones. We talked about this a little bit, I believe it was the first week. Transport zones are one of those things where even for our largest customers with crazy designs, just do one transport zone. The only use case I've ever seen where they've used two of them is going to be if they have VDI and server mixed into the same workload, which isn't against best practices, or is against best practices as it is. So it's one of those things where generally just stretch the transport zone as far as you want your logical switching and routing to traverse. Just have one global transport zone. So this is just kind of a visualization here. We've got our cluster here. We've got the VTEPs, we've got our compute VDS and our edge VDS, and we've got that VXLAN transport zone that spans all of those clusters. Replication modes. We talked about this when we were talking switching. Multicast mode. If you don't have multicast configured, that's IGMP snooping and stuff like that on your switches and PIM multicast routing on your routers, don't use multicast, just use unicast. That's what it's there for. 99% of our customers are using unicast mode. If you do have multicast available to you, then you can definitely look at the multicast modes, whether that be hybrid or multicast. If you want to know more about those, then definitely go back to last week's switching and routing talk, and we did talk about that for a little while. I should have hidden this slide. We already went over this in the routing, sorry. High availability. So when you're designing high availability for your edge services gateways, the biggest question that you're going to have is, how much throughput do I need? If you've got more than 10 gigs of north-south traffic, you should make a design decision to go ECMP. If you've got less than that, then you can definitely go active standby. Now, there is a little bit of downtime for that failover depending on how you have your timers tuned. If you don't want to have that, you can definitely go ECMP so that you can have an entire edge go down and there's no failover time. It's just automatically rerouting through the other edge services gateway. So with an active standby model, I've talked about this several times again, design decisions. If you need stateful services at the edge, then you have to go with active standby and not ECMP. I know that they are working on changing that so that you can do some of that, but the fact that you're doing asynchronous routing through an ECMP model kind of ruins the statefulness of your edge. So if you need stateful services at the edge, then definitely go with an active standby model. And that 10 gigs, if you have, say, a design decision where you've gone active standby because of the stateful services, but you need more than 10 as a requirement, then you can definitely deploy multiple pairs and set them up as kind of tenants through the inside. And you can route through the two, but you can have two separate edges that are doing that. And that gives you the aggregate 20 gigs throughput with the stateful services. Sizing, we talked about kind of why you would want to size up to the different sizes. Again, make sure that you choose wisely because you cannot scale down, you can scale up. If you're going to be doing any form of load balancing, go extra large. You won't regret it. That's really where all of the performance and stuff starts to take a hit, is if you're doing large and quad large with some really, really high performance load balancing. So distributed firewall design considerations. Using the applied to field limits the scope of the policy. Now we say that your distributed firewall only publishes the rules to the VMs that are on that host at that time. Now that is true, but if you scope the policy down, it kind of cuts down on some of those rules that may be around that don't need to be. So in terms of performance, if you're trying to get the most performance out, tune that applied to field as low as you can go. So say if you're doing a policy that involves any VMs on a logical switch, apply that policy just to that logical switch, or even just that couple of hosts that that VM might be on at any time. Definitely designing distributed firewall policy is important. vRealize Network Insight can help you do that, or of course our PS resources or even a partner PS resource can help you do that. You can absolutely take the awesome features and performance of our distributed firewall and screw it up by taking the policy that you have in your existing firewall today and simply dumping it over into DFW. You're not taking advantage of the security groups and naming conventions. You're not at that point in time taking advantage of a lot of the grouping and scoping that we can do with distributed firewall in terms of designing for performance.
Tim, just
yes, sir.
Something from that previous slide. It said that a behavior would change in 6.2, but I think we're already in what, 6.2.4?
We are in 6.3 right now. So again, I apologize. I didn't go and update some of the information here. It hasn't been updated just yet since 6.3 just released here recently. But yes, that change has already been made.
All right. Thank you.
Mm-hmm. And we're here at 8:30. I have just a few more slides. Do you want me to keep going? Do you want to give people the chance to drop off?
Keep going, man. All
right. Shouldn't be too much longer here. My apologies for running over. So the DFW applied to field, we talked about how important this is. This is just kind of a mock-up that we showed earlier. RBAC. This is another one of the very biggest things that you can do. If you've got vendors that are walking in saying VMware is going to take away your networking and security and give it to the VMware guys, again, ask your VMware guy if he knows how to troubleshoot BGP. Ask him if they know what zero trust security is and tell them they can't Google it. We can absolutely design NSX where your networking guys can touch networking things and that's it. Your security guys can touch security and that's it. You can have it where your VMware admin logs in and they don't even see that NSX is installed. It all depends on how you want to design your security. You absolutely have to have SSO on your vCenter server. If you're using vSphere 5.5 U3 and all that, which is our requirement for NSX, you've already got either multi-site or PSCs and stuff like that. Especially at 6.0, you've got PSCs and you've got an SSO domain. That's one of the ways that we use for RBAC. NTP. Your NTP design is crucial, and I say that for any VMware product. NSX is highly distributed, so this time has to be in sync. So if you don't know what NTP is or you're not super familiar with it, I urge you to go and look at it and be familiar with it. If you're using any form of highly distributed systems, NTP is important. If you start going out and deploying all of this stuff with NTP out of sync, you're going to run into errors. Although most likely in your vSphere and vCenter environment, you're already running into problems. You just might not know it yet. and also DNS. DNS is crucial. Forward and backward DNS for everything. That way, make sure you have all the stuff set up like for NSX Manager before you deploy. So here's some of the rules and scopes that we have for RBAC. Enterprise Administrator, NSX Administrator, Security Administrator, and of course, Auditor. If you have a QSA for PCI, give them the Auditor role. They can go in and look at whatever they want without touching. The scope is the really cool part. So if you have a multi-tiered service provider type deployment, you can give somebody Enterprise Administrator access only to their specific Edge Services gateway. They can't get to anybody else's ESG. So if you're doing a service provider type thing, you can give that customer full access to their edge. They can't go to your provider edge or to another customer's edge. Or if it's you can give yourself Enterprise Administrator with no scope or no restrictions so that you can get everywhere. We kind of give you that power to design your security the way that you see fit. If you need to push your security to 11, we have partner integration with HITRUST, which will take and turn every single little nerd knob in your environment into a checkbox where you can say, well, this person can log into absolutely everything, but they can't touch that one little obscure button. They do that by basically putting a proxy in front of your vCenter server so that all of your traffic and logins and everything gets sent through that. And it's also really good for audit logging. So you can go through and say, so-and-so logged in at this exact second and touched that exact button and then logged out. If you're in government environments or something where regulation is heavy, that might be something that you'd look into. And that's it. We are done with the NSX series. Thanks for playing along.
Tim, we actually want you to keep going. Don't you have like a lab? No, I'm kidding. I do have a couple questions. I do have a couple questions.
Absolutely.
Grant Mitchell asked us, how well does NSX work or integrate with vSphere integrated containers?
Okay, so containers are a big thing. I'm not so keen on the containers at this point in time. We absolutely have stuff that's in the works for NSX with containers. In the coming months and years, you can see that to get a lot better. At this current point in time, you're pretty much just like building distributed firewall policy based on the VM itself, not the actual containers. But that's going to start changing. Be on the lookout for that. I can't really dive super far into the container thing right now.
Okay. And the other question is, can role-based access control use two-factor authentication, or is that client OS dependent? What would happen if someone asks you about
At this point in time, our RBAC it just is real basic. When the user logs in, they get what you see. We don't control how the login works other than basically like connecting to LDAP or Active Directory, just like you do in vCenter server. If you need something like that, I believe HITRUST has an integration with 2FA where you can complete that kind of two-factor authentication. We don't do the authentication part. We just say that once they get logged in, this user account can do X, Y, and Z.
Okay, it may be that since vSphere 6.5 supports RSA as well, it may be that would be a way.
Yes. So we use the same SSO domain login stuff that vSphere uses. So if vSphere 6.5 supports RSA for two-factor, then you can use that same two-factor login. And then once you get logged into the web client, you would use any other role-based access control to select what they can and cannot see and do in NSX. Because all we are with NSX, we're not a separate product that you log into. We're just a new tab in your vCenter server that you can click on and go into to configure. So as far as logging into vCenter, that's whatever the standard login process is.
Awesome. And I do have one question. You mentioned VCDX. Are you a VCDX?
I am not a VCDX. I hold
Are you working
3
towards it?
VCAs, 3 VCPs, 2 VCAPs, and a VCIX, and I am writing VCDX as we speak.
Very good.
It is such a brutal process, and it's taken me so much longer than I wanted it to be. Anybody that tells you that there is a way to balance work, home, and VCDX is a liar. They're an absolute liar, because there is no balance. One of them suffers, period. So I highly recommend, if you are not one, that you should look into what the process is. There's a new group that just got done this past week. We currently have, I think it's 257 of them, which in the grand scheme of things is not a lot of people, but hopefully that number explodes over the next few years.
We look forward for you showing us your VCDX design decisions in the future vBrownBag.
I hope so, man. I hope so.
We got one final question from Nick Tonchev. He's asking if the permissions are set at a vCenter level for NSX. Is it in the same familiar interface, or do you actually do it in a different way?
So there's actually two different places for that. When it comes down to actually seeing NSX in vCenter server, you use the standard vCenter roles location. When it comes down to actual RBAC within NSX, that's going to be within the NSX client, or within the NSX tab and configuration. So there is two different places. The standard vCenter is just where you can see that tab. So if you log in and you can't see the NSX tab, you have to go to the normal SSO administrators to give that role. Once you get in there, you can actually say all of the little RBAC stuff for firewall and networking and all that in NSX.
Awesome. Tim, I just can't thank you enough for committing yourself to doing 3 weeks of NSX for vBrownBag. It has been a pleasure.
It was awesome, man. And I remember when Fraps asked me about doing that, or you did, or somebody did, like 6 to 8 months ago. They were like, it's not going to be until May. And I'm like, oh, cool. That's future me's problem. And then here it is, and here we've been. It's been awesome. I think it's went really well, and I appreciate everybody for checking it out.
Yeah, it's been great, Tim. We really appreciate it. It's a great service you're doing to the community. One last question is, if people want to learn more, how can they learn even more about NSX?
That's fantastic. Google search it. There is so much out there for NSX right now. Jason Nash has a dated but still fantastic Pluralsight series. We've got some free NSX modules on the VMware education site, mylearn.vmware.com. If you want to actually get in there and get your hands dirty with it, you can go through to labs.hol.vmware.com, log in, and start using NSX immediately. If you've got a home lab and you want to deploy NSX, you can now subscribe to vMug Advantage for $200 and get an access to NSX Enterprise licensing. This is a new thing. It's really big. It's really awesome. We also have NSX ICM courses if you want to go through and deploy NSX and learn how to do that to start to get certified. We have optimize and scale classes like that, like the VCP one for data center virtualization. We have stuff like that for NSX. I believe we have a troubleshooting workshop too that's new, that's going to be pretty awesome. Reach out to your core account teams if you want to talk about your company in NSX. Your company most likely has a VMware rep assigned to it, and most likely in your area you have an NSX SE just like me that's assigned to your accounts. If you need help finding out who your NSX account team is, you can always ping me on Twitter and I can help you find that out. You could also go and get the VCP NV book for learning NSX. There's so many different things. Oh, YouTube. The VMware YouTube, we do these things called lightboard videos, which if you're not familiar with it are really, really cool, where you see people in black shirts like drawing on the screen. There is a whole series on NSX and security for those lightboard videos that are really cool and a really great place to start. So many different ways. If you need more ways, feel free to reach out.
We also got Josh Andrews tell us, don't forget the official training. There's actually a class coming up in Chicago in 4 weeks that is 50% off.
Yes, so he actually just posted that on the VMware Reddit page. We are doing I think it's a beta of the new NSX 6.3 class in Chicago, 50% off. If you've got a training budget and you don't want to blow all of it in one time, that class is going to be awesome. It's going to be really, really cool. So definitely check that out as well. You can find that from mylearn.vmware.com.
Awesome, great.
All right.
Sounds like there's tons of places to learn about it then.
Absolutely.
So I guess there's no
thank you so much again.
other questions. All we can say is thank you. And what was that, Ariel?
No, thank you so much.
Absolutely. Thanks for letting me run over a little bit, guys. Appreciate it.
Anytime.